In example 2, we are going to graph two full periods of y equals cosecant of x plus pi over 2. In order to graph this, we are going to take a look at the sine graph first. So first, let's look at the graph of y equals the sine of x plus pi over 2. And the reason we chose the sine graph is because the cosecant and the sine are just reciprocals of one another. So we're going to find all these points in here just like we would with the sine and cosine graphs. In this case, with our sine graph, we're going to start again here with the x plus pi over 2, and those are going to be our first 5 key points, just like in section 4.4. So those values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then evaluating those at the sine of x, right, the sine of 0, sine of pi over 2, getting those from the unit circle, these are 0, 1, 0, -1, and then 0. And then what we had to do is we have to take whatever this is and set it equal to each one of these key points to get our x value that we want. So we're going to take x plus pi over 2 and set it equal to 0. Subtracting pi over 2 from both sides, we get x is equal to negative pi over 2. So that's our first x value. Then we're going to take that x plus pi over 2 and set it equal to pi over 2. Well, if we subtract pi over 2 from both sides, we get x equal to 0. So 0 is our next x value. Then we're going to take that x plus pi over 2 and set it equal to pi. If we subtract pi over 2 from both sides, we get x equal to pi minus pi over 2. And then we need to get common denominators. So pi we can look at as 2 pi over 2, giving us x equal to pi over 2. Next, we take x plus pi over 2 and set it equal to 3 pi over 2. Subtracting pi over 2 from both sides, we get x is equal to 2 pi over 2, and 2 pi over 2 is the same thing as pi. And finally, we take x plus pi over 2 and set it equal to 2 pi. So x is going to equal 2 pi minus pi over 2. And then again, we need common denominators in order to subtract, so we can change this to 4 pi over 2, giving us 3 pi over 2 as our final x value. And then in order to find over here, we are looking to see if we have anything we need to multiply by or add or subtract to it. And the answer to that is no. There's no amplitude that we need to worry about other than 1, and there's nothing that's being added or subtracted. So these same numbers are just going to come in this last column. So we have 0, 1, 0, -1, and 0. And this right here is one full period. So we are asked to find 2 full periods. So below, we'll have to take that into account after we start graphing it. So let's get our graph set up. And with our graph, we're going negative pi over 2 to 0 to pi over 2 to pi to 3 pi over 2. So that's one full period. Now remember, we want 2 full periods. Let's start with what we have here. And again, we're going to graph that sine function first, looking at the sine function. And we're going to graph that as a dotted line. So the sine function that we have the point negative pi over 2, 0. Then we're going up to 1 and to -1. So then we have 0, 1. We have pi over 2, 0. We have pi, -1, and 3 pi over 2 is 0. So here's kind of our dotted line to start us off. And remember, that's one full period. If we want 2 full periods, we need to keep going. You can go in either direction. So you can add a period this way, or you can add a period going in the positive direction. It really doesn't matter. I'm just going to continue on in this positive direction, noticing that I'm going up by pi over 2. So then I'm going to add on After 3 pi over 2 would be 4 pi over 2, which simplifies to 2 pi. Then 5 pi over 2. Then 6 pi over 2, which simplifies to 3 pi. And then 7 pi over 2. So if I continue on with another full period, I'm going to go up at 2 pi following my pattern. So notice I started at 0, I went up, back to 0, I went down, back to 0, so I'm going to go up, then I'm going to go back down to 0, then I'm going to go down, and then back to 0. And I get another full rotation, another full period of my sine graph. Now to draw in my cosecant graph, I'm going to take and put asymptotes whenever the sine graph is 0, because this is when the cosecant is undefined. So let's go ahead and draw in those asymptotes. Asymptote should always be dotted. And then what I'm going to do is if I take a look at the high points and the low points, those are going to be where my U shapes are coming off of. Remember, I'm never going to go down below this line, this midline here. So this indicates that I'm going up, and then this lower point indicates that I'm going down. So my graph looks like this. I'll have a U shaped here, a U shape going down in this direction, then up, and then down. So 2 full periods of the cosecant graph. This is one up, one down is 1 full period, and then I added another up and another down to get 2 full periods for my cosecant graph. If you have questions, please let me know.